given 3 electron configurations, and we're asked to identify which one has the largest first ionization energy and then which one has the smallest second ionization energy. So let's do the first ionization energy first. What that means is the energy required to remove the outermost electron from an atom in its gaseous state. All right, so let's do, I'm going to mark this in green. We're looking for the valence electron. Those are your outer energy level electrons. That is closest to the nucleus, because that's where the electrons are attracted to, the protons in the nucleus. So the closer they are, the harder it's going to be to remove those electrons. The farther away they are, the easier it is going to be to remove, because they're farther away from what they're attracted to. So to find the scenario where it requires the most energy, the largest energy to remove that outermost electron, we're looking for those valence electrons to be. So the answer is going to be the first choice, because all those electrons, the farthest one is in the n equals 2. And not only that, when you have this format, ns2, np6, where n is the principal quantum number, the energy level, this is a characteristic of noble gases. So it has a full energy level of electrons. So that's also going to add to its stability. So this is going to be your answer. It happens to be neon. Okay, so when you have neon, it has 10 electrons. All of those electrons are going to require a significant amount of energy, relatively speaking, compared to these other ones. I can tell they're metals because they only have 1 valence electron, 2 valence electrons. All right, and it's not asking us for this, but this one would be the largest first ionization energy, and this one would be the smallest first ionization, and this is sodium, by the way. Because it only has 1 electron, it's going to be easiest to remove that one. All right, let's move on to part B, where it's asking us now what is the smallest, not the first ionization energy, but the second. So after you've removed the outermost, the next one to go. So which one would it be? Is the easiest. So smallest amount of energy is the easiest to remove that second electron. Well, the answer is going to be the second. This one, both these electrons are valence electrons, so both of them are going to be easier to pull away than any core electron. So this one happens to be magnesium with 12 electrons, and I'll just draw this out for you using kind of a Bohr model. So 12 electrons, 2 is going to go in the first energy level, 8 in the second one. I'll just draw them out real quick. Those are we know they're not in orbits like this, but and then magnesium has 2 valence electrons in n equals 3. So now both of these are going to get removed much easier than any of these core electrons. This is the core electrons. They're going to, so those first two on the valence, not too bad. Anything after that, it's going to require much more. So that's why that's going to be the answer. The reason it's not the middle choice is sodium. Right, sodium has 11 electrons. So there's 2 in the 1s orbital, 2 s orbitals, 2 p orbitals, and it has 1 valence electron. Sodium does. So this one's going to be the easiest of the 3 to pull away. It'll be the lowest ionization energy. But the question's asking what is the second ionization. Well, now you're dipping into the cores, and that's why that's not the answer. That's why sodium is not the answer. The answer is magnesium.